In this video I'm going to be looking at some simple conversions. So conversions between polar coordinates and Cartesian coordinates both ways, and conversions between polar equations and Cartesian equations again both ways. So first up is these. So find the polar coordinates. Sorry, but I get fed up of writing the whole word, so I'll just write chords. Find the polar coordinates of the points with Cartesian coordinates, these. So these are Cartesian coordinates, and we've just got to convert them into polar coordinates, okay? My suggestion is you just draw a quick sketch to see what it looks like. So Cartesian coordinates, 2, 3, so this is a Cartesian coordinate axis system, and 2, 3, somewhere there, isn't it? Okay? And we've got to work out what the polar coordinates are. So if you want, you either imagine a right angle triangle, or you just draw it in. If that has got coordinates 2, 3, then that will be 2, that will be 3, and the first thing we do is work out what the value of r is. And you do that using Pythagoras Theorem. Do you remember this result I showed you? Okay, I've written it down for later on as well. R squared equals x squared plus y squared. Well, that is simply because in this right angle triangle, that value of r is always going to be the hypotenuse, isn't it? So you've got, in this case, r squared is equal to 3 squared plus 2 squared, okay? So you've got r is equal to the square root of 13, all right? And then for the angle theta, that angle there, you just do the inverse tan or arctan, whichever one you prefer. I prefer writing that because it's just quicker, okay, of 3 over 2. And remember, when you're doing this, make sure your calculator is in radians mode, right, as mine isn't. It should have been. I was probably doing a GCSE question before this. So angle unit, put it into radians. There we go. And ready to go. So just do inverse tan of 1.5. Okay, and that gives us 0.983. 0.983, and I've just rounded that to 3 significant figures so that you know. Okay, so the first one there, where can I write it? I'll write it here. First one here is going to be, shall I write in a different colour? Yeah, it's right in a different colour. It's going to be root 13 and 0.983. Okay, and that's it. That's the first one. Right, next one. Let's just get the board rubber and let's do the next one. 5, negative 12. I'm going to draw the graph down here this time. So quick sketch. That is an awful sketch, I have to say. But there you go. 5, negative 12. So somewhere down by there, isn't it? Okay. So that's 5, negative 12. Okay. And then that's just a habit of mine. Put in the x and y for the Cartesian coordinate system. So that's going to be 5, that's going to be 12, so r is going to be 13. Got Pythagorean triple there. Okay, so I'm going to put that in straight away. So the r coordinate is going to be 13, and then for the value of theta, I'm going to work out the inverse tan of 12 over 5, and let's see what that is in radians. Again, so inverse tan of 12 over 5 and 1.176. There we go, 1.17. Can I put 1.18 just to be, consistent with the 3 figures? So 1.18, and notice that's below the x-axis, so I'm going to record that as a negative value. Okay. Remember, with polar coordinates, you can either have values of 0 round to 2 pi, or 0 to pi, or 0 to negative pi. Okay, or negative pi to 0, strictly speaking, but yeah, you know what I mean. Okay, I'm hoping that for those who've seen this, this is exactly the same, really, as what we do with complex numbers, isn't it? When we're looking at modulus and argument, converting Cartesian into modulus argument form. Okay, it's exactly the same thing. So it's really, really simple stuff. Okay, and actually there's a lot of crossover between the work we're doing now and complex numbers and vectors work and lots of other things. It all goes together, and that's lovely. I find that lovely. Okay, I find it satisfying as well when you're able to talk to your classes about how all the different facets of mathematics are linked together. It's really great. Okay, so negative root 3, negative 1, so that's somewhere there. Okay, Right, there it is. So negative root 3, negative 1, and then that will be root 3, that will be 1. Notice how when I'm doing these, I'm writing in positive values only, okay, because all of this is about lengths and distances, okay, and modulus, magnitude, okay, and so on. So positive values are generally needed. Okay, I've already mentioned that r is always going to be positive because that stands for a radius, a magnitude, a length, okay. There isn't, of course, is an angle, okay. So I put in there root 3, 1, so Pythagoras Theorem, what's that? So it's 3 plus 1, so the modulus of that is going to be 2, so r is 2. And then for the angle theta, now what I'm interested in is that angle there. There's several ways of doing it. You can work out that angle there if you wish, but I'm just going to go for that angle there. So I'm going to write in, I'll tell you what, no, I'll keep it as it is. I'll go for a different letter. I'm going to keep theta there, okay, because it doesn't matter, it's only working. So inverse tan of 1 over root 3, and that's our radius, so it's pi over, I better check it, okay, inverse tan 1 divided by square root of 3, okay, I'll put the bracket in the wrong place. Again, put the bracket in the wrong place. It's so fiddly. Okay, pi over 6. Yeah, pi over 6. So it's always well to check it, even if you think you're certain. It's always well to check it. But what I want is that angle there, of course, for my my angle, my argument, my coordinate that goes in there. Okay, so pi subtract pi over 6. 5 pi over 6, but remember it's a negative, isn't it, because it's below the x-axis, so negative 5 pi over 6, okay, so that's it, so it's pretty simple stuff really, okay. Okay, next up, so we've got these polar coordinates given here, and we've got to convert them into Cartesian coordinates. Now these are actually much easier, very quick to do. So I'm just going to give you a quick reminder here of some notes I gave you last, or in one of my previous videos. Remember that x is r cos theta and y equals r sin theta? Well, we're going to use that, okay? Hopefully you remember why that is, because if you have your Cartesian coordinate system drawn out here, okay, and then if that's your coordinate, x, y, then that's the x coordinate, that's the y coordinate. You can see theta, using simple trigonometry in a right angle triangle, you've got x is equal to r cosine theta and y equals r sine theta, okay. So yeah, all you need to do is just use those and use your calculator, that's it. Okay, so for the x coordinate, I'm going to do r cos theta, so I'm going to type in 10 cosine 4 pi over 3. So 10 cosine 4 pi over 3 and negative 5. That's it, done. Okay, so that's the x coordinate. Okay, and then for the y coordinate, I'm going to find r sine theta. So this time I'm going to type in 10 sine 4 pi over 3, negative 5 root 3. That's it. Could not be simpler, could it? Could not be simpler. It doesn't matter what those values are. You don't have to worry about what where they lie in a coordinate system, which quadrant they're in, okay, you just type it in your calculator. Let's do another one then. So this will be x is 8 cos 2 pi over 3, so 8 cosine 2 pi over 3, that's negative 4. And then this one will be, the y coordinate that is, will be 8 sine 2 pi over 3, 8 sine 2 pi over 3, so 4 root 3. Okay, 4 root 3. Done. Probably the easiest bit in the whole of this unit, polar coordinates. Okay, next we're going to do some symbol conversions with equations. So here I've given you 3 polar equations, okay, and we need to convert those into Cartesian equations because it's helpful, isn't it? Basically, it's helpful for a lot of reasons. Okay, whether it's drawing graphs, solving equations, whatever, we need to be able to convert these things. Okay, so r equals 7. R equals 2 plus cos 2 theta and r squared equals sine 2 theta. Okay, I'm just going to remind you about these because these are absolutely crucial now in enabling us to convert those from polar to Cartesian form. Okay, so For this one, you've got r equals 7. We're going to use that. Okay, do you remember? I've spoken to you about that already. So if you've got r squared equals something, then you can do it. Okay, and quite often as we're trying to, in this, write down what r squared equals. Okay, so you've got r equals 7, so r squared equals 49. So that means x squared plus y squared. I'm going to write it in by here because we're done. X squared plus y squared is equal to 49. Okay, and that's it. We're done. That's the equation of a circle, of course. I'll be doing a different video on graph sketching. Maybe you've seen it already. Okay, but I'm not doing any graph sketching in this. I'm just doing the conversions. Okay, right. This one here. Well, hopefully you can see we're going to have to make use of not just this one, but one of those as well. Okay, but the thing is, the angle is 2 theta. We're going to have to use a trigonometric identity. Okay, in order to get an angle in theta, because we can't do this without using cosine theta or sine theta. Okay, so what I'm going to do is I'm going to rewrite it as r equals 2 plus, and then I'm going to use the identity. Cos 2 theta is the same as 2 cos squared theta subtract 1. So you got r is equal to 2 subtract 1, which is 1, plus 2 cos squared theta. Okay, but I can't actually use this yet because notice I need an r there in front of the cosine theta. The simplest and quickest way to do this with all these types of questions is just to multiply throughout by r, okay, or r squared, because I've got cos squared theta there. So if I can use that, that would be x squared equals r squared cos squared theta. So I've got to multiply both sides by r squared. I'm going to write that on the side there. Multiply both sides by r squared. So that means on the left I'll have r cubed is equal to r squared plus 2r squared cosine squared theta. Okay, and then I'm ready to go. I'm ready to substitute these in. Now, don't worry about what power you get there. Okay, that's easily dealt with because see this here? If r squared equals x squared plus y squared, then it's quite easy just to find out what either r is. R, of course, will be the square root, positive square root of x squared plus y squared, and then r cubed will just be the cube of that. Okay, so let's just write that in. So remember, r squared is x squared plus y squared, and then r will be that to the power of a half, and then r cubed will be that to the power of 3 over 2. So that's the left hand side. Okay, sorry I've not been able to match it up perfectly. The equal sign has just gone over there now. Okay, and then r squared is just x squared plus y squared. This is getting in the way a little bit now. Let's just put it under there, x squared plus y squared. I don't think it's going to be in the way, it kind of is. And then this bit here, the 2 r squared cos squared theta, that's just going to be 2x squared. Okay, 2x squared, written like that. Okay, and that is it. That's the Cartesian form. Okay, you don't have to worry about tidying it up or anything or rewriting it differently. That'll do. That'll do as our Cartesian equation. Okay, so can I squeeze it in up here? Because it's in black, it's okay, I think. X squared plus y squared to the 3 over 2 is equal to x squared plus y squared plus 2x squared. It's also a nice reminder at this stage as to why we sometimes use polar coordinates, because written in Cartesian form doesn't really look that nice, does it? It's not that convenient, it's not nicely, it's not a great expression. Whereas in polar form, much simpler. Okay, even this one, the circle. I mean, we don't mind that because that's quite a common one in Cartesian coordinates, isn't it? But just r equals 7. So it's a reminder at this stage as to why polar coordinates exist, why they're there. Sometimes it enables us to write equations in a much simpler form. Okay. Now let's do the last one. Let's just rub all this off. Tempting as though it might be, you might be thinking, well, I've got r squared there, let's just put in x squared plus y squared. You can do that, but I generally don't until I'm ready to substitute everything in. What I mean by that is I want to be able to substitute the trigonometric term in as well. Now what you notice is this one, again, that's in terms of sine 2 theta. We want to use an identity to get it in terms of 2, just theta. Okay, so I'm going to write it as r squared equals 2 sine theta cosine theta, like that. Now, what you'll notice is well, I'm going to have to use both of those now because one of them is sine, one of them is cosine. But again, I'm missing the r in front of each one. I need an r there and an r there. In order to get that, I need to multiply both sides by r squared, okay? And so the left-hand side, you get r to the power 4. That's why it wasn't a good idea to substitute that in straight away, because now I've got r to the power 4. And then let's write, it says 2r sine theta, and then r cosine theta. Obviously, I could write it as 2r squared sine theta cosine theta, but I'm just making the point that this bit there is that, and this bit there is that, okay? So r to the power 4, I do like it, it's even powers because it makes it much easier. So r squared is x squared plus y squared, so to the power 4 will be that squared. Okay, and then on the right hand side, we've got 2, and then r sine theta is y, r cosine theta is x. So let's just write that as 2xy, shall we? Okay, and then that's it, that's done. You don't have to rearrange it. If it just says find a Cartesian equation, that is it. Remember, a Cartesian equation just means has to be an equation in terms of x and y only. Before I end it, let's just talk about this bit here. What's going on there? Why is the domain there somewhat limited? Well, if you think about it, when you're doubling the angle, that means you're doing the sine of an angle between 0 and pi when you're doubling it, okay? And on the sine graph, quick sketch of that. Oh, there we go. Between 0 and pi, there it is. You can see all the values are positive, so not got a problem. But if you're going to extend that, okay, if you do the sine of an angle between pi and 2 pi, in other words, if you have a value of theta between pi over 2 and pi, then what happens is you get a negative value, okay? And we've got r squared on the left-hand side, and we do not want to have r squared being a negative value, okay? So that's the reason why this domain was somewhat restricted, okay? Sorry, not quite done with it yet because I was about to rub all of this off and go and do something else, and I just quickly saw that this, I can just simplify a bit, can't I? I don't know why I didn't see that earlier. Maybe you spotted it, I hope you did, okay? But I'm kind of a almost completist, perfectionist type of person. I just want to put that in, okay? So I'm just going to tidy that up by saying that the x squared plus 2x squared is equal to 3x squared. I'm going to remember the plus y squared, okay? So 3x squared plus y squared. That's all I wanted to say about that. It's fine, you wouldn't have lost marks for it because, as I said, it just says find a Cartesian equation, so no simplification needed. But if there's an obvious simplification, yeah, do it. So there, I feel happier with that now and ready to go on for the next set of examples. Okay, next up we're going to look at conversions between Cartesian and polar equations. Okay, so here's a Cartesian equation and I convert it into polar. Okay, I've got 3 examples to show you. Now with these, it's quite simple. Wherever you can, substitute in what we know for y and x. Okay, so now y is r sine theta and x is r cos theta. And that's it, that's your starting point. So starting off with these is generally quite easy. So y squared, so that will be r squared sine squared theta. And on the right hand side, we've got x, which is r cosine theta. Okay, and we've started off. Now we've gone from Cartesian to polar equation. With these, try and simplify it if you can. Sometimes they're really simple. Like an obvious one is to divide that by r. So you've got r sine squared theta on the left, and you've got 4 cosine theta on the right. Now if you can, try and make r the subject. Okay, and that's generally pretty easy. You just got to bring that over to that side there. Okay, so your r is equal to 4 cosine theta divided by sine squared theta. So I'm going to write that as over sine theta, like that, and then over another sine theta, just to make it clear as to where the next line is coming from, because that is cot theta and that is cosec theta. So I'm going to write that as 4 cosec theta cot theta. That's the preferred way of writing it, alphabetical order, you see, COS before COT. Okay, yeah, and that's the first one. Okay, next one. So x squared minus y squared equals 5. Again, the method is wherever you see x and y, just substitute these in. Okay, so the x squared, that will be r squared cosine squared theta, and then the y squared, that will be r squared sine squared theta. Okay, and then just equal to 5, and then again, done it. Step 1 done, converted from Cartesian to polar. And now just do a little bit of simplifying with this. So the first obvious one is to factorise, because with polar form, you always want to have just a single value of r, okay? You don't want to have r in two different places where possible. So you have r squared, and then cosine squared theta minus sine, whoops, there's a square that went missing somewhere. Sine squared theta is equal to 5, okay? And do you notice that? What the identity for that is? Hopefully you do. That is the same as cosine 2 theta, isn't it? Okay, so you can see how we just simplified that quite a lot. Now, we're not really going to be able to conveniently make r the subject in this one, so the next best thing is to make r squared the subject, okay? And that's what we're going to do here. It's like in this one, with the Cartesian form, it's not convenient to make x or y the subject, is it? So we just keep it as x squared and y squared. Same with this. And we're going to put that onto that side. And the most convenient way of writing that is to write it as 5 sec 2 theta. Okay? And that's that one done. Okay, next example then. So as with before, we're going to replace y and x with these. So that's going to be root 3 r sine theta. And the right hand side, that's going to be r cosine theta plus 4. And then we're just going to try and simplify it a little bit. Let's put all the r terms to the left, shall we? Because traditionally it's r equals something in terms of theta. So basically, I don't know why I didn't write this up earlier actually. You try to get everything in the form r equals some function of theta where possible. Okay. So let's do that and factorise at the same time, shall we? So we'll have r and then root 3 sine theta, subtract cosine theta, and on the right hand side we've got 4. Okay. Now we're going to try and simplify it if we can. See any decent ways of simplifying that? Some sort of trigonometric identity is needed, isn't it? But it's looking like, if I can just write using a different colour, where's my black pen gone? Get rid of this now, I think. Make some space. It's looking like it's one of these, isn't it? It's looking like it's a sine A minus B identity. Do you remember what that one is? So sine A cos B, subtract cos A sine B. Okay, it's looking like one of those. Okay, only obviously when we do the sine or cosine of an angle, we're not going to get root 3, are we? So the thing to do is to divide both sides by 2. Okay, so what I'm going to do is I'm going to write it as r, and then in brackets root 3 over 2 sine theta, subtract 1/2 cosine theta is equal to 2. Okay, maybe I'll just put there, I've divided both sides by 2. Okay, and then I can try and match these up. So it kind of looks like the A term there is theta. Okay, so I'm down on one knee. There we go. Can you see that? So in other words, the sine theta cosine B is equal to this. So that means we must have cos B is equal to root 3 over 2. And the other term, that there, is going to be equal to this. So it must be that sine B, they're both negative, sine B is 1/2. Okay, so sine B is equal to 1/2. And as long as we can find an angle B that matches both of those, that satisfies both of those, then we've done it. Okay. Now, off the top of my head, sine pi over 6, sine 30 degrees is 1/2. So let's just try that one, see if that will work. So pi over 6, and cosine pi over 6, cosine 30 degrees is root 3 over 2. So that works nicely. Okay. So that means is we can rewrite this as r sine, and then this bit here, isn't it? Theta subtract b, where we found that b is pi over 6. We can write it like that. Okay. Why would you want to do that? Because what we've done, of course, is we've just effectively rewritten two trigonometric terms into one. Okay. Sometimes the simplification process is the hardest bit, but it's a nice reminder, I suppose, of how you've got to be really on it in terms of your trigonometric identities. Okay. You've either got to have them memorised or know where to find the appropriate ones in the formula booklet. Okay. And let's go round it off by writing down our final answer. We want to have r as the subject, so I'm going to r equals 2. And if I put this into that side, that will become cosec 2 cosec theta minus pi over 6. Okay, then we're done. Okay, I hope you found those helpful. I find them great. They're quite nice to get into. Okay, nice bit of mathematics, coordinates, trigonometry. Yeah, it's great. Well, I'm hoping you enjoyed it, is what I'm saying. Okay.